This lesson, we're going to talk about conditional probability and dependent event. So the conditional probability, you use the sign of this bar as the conditional, and meaning of the conditional probability is the probability that event B happened given that event A has happened. So they are related, right? So you can only have B happen if A happened. That's going to be conditional probability. And then we're going to talk about dependent event. We talk about independent from the previous sections. And the events are independent. We say that you're just going to multiply the two events to get that independent event. But if it's a dependent event, you are multiplying two events, but you don't multiply with probability of A and probability of B. You multiply probability of B given A because they are related, right? So that's the different formula we're going to use if we realize the given problem is dependent. So you need to be careful with that. So when you're looking at the first problem, it's what is the probability that two cards thrown at random from the deck of a deck of playing card will both be ace? They didn't mention about replacing back the card or anything like that. They said that the two card is randomly selected from the deck of the card, right? So we're assuming that we're not replacing back. In that case, depends on what you got on the first one, your probably will be changed on the second event. So this is going to be dependent event, right? So you're going to find your probability by the first time it happening is going to be 4 ace out of 52. And then you multiply this by second time you happen, you are assuming you already got one ace out of 4. So the second time you only have 3 remains out of total of now 51. And this will give you 12 times 2,652. And when you reduce that, it will be 1 out of 221. And this is dependent event. Let's look at the example 2. Let's say find the probabilities. Find the probability that a dice roll shows a 6, given that a flip coin shows a head. So here is two concepts that I already see that's going against each other in these problems. The first one is given that. So whenever you have given that, this is going to be conditional probabilities. But then you notice that finding a probability of rolling a dice versus flipping a coin, this is going to be independent event. So even though it's a conditional probability, this is going to be not related event, right? Finding a probability of rolling a 6 is just coming from here. Nothing to do with this area, right? So it's just the tricky problems. That's going to be 1 out of 6. What about example 3? Example 3, you have a table. It shows that speeding ticket by different colors. So you have a red car and not red car, right? And the red car, there are 15 cars got speeding tickets, 135 didn't get speeding tickets. So there are a total of 150 red car. Non-red car, 45 get speed ticket and 470 didn't get speed ticket. Total of non-red car is 515, right? And total of the car who got a speeding ticket was 60. Not getting speeding ticket is 605. So using this, they wanted to know, has a speeding ticket, so find the probability that a randomly chosen person has a speeding ticket given they have a red car. So they wanted to find the red car out of red car who have a speeding ticket, right? So that's going to be 15 right here. So, in order to write that, a probability of speeding ticket given that, so that's going to be conditional, red car is going to be 15 out of 150. So it had to be red car. So you're not looking at all the total number of the total number of the car. So your conditional is the red car. So your total have to be only red car total. So it will be 150 and speed ticket will be 15, right? Only from the red car again, right? So you can write it as 15 out of 150, which gives you 1 over 10 or 0.1, right? What about the second one? It's has a red car given they have a speeding ticket. So red car given speeding ticket. So for this one, your total had to be speeding ticket. So the total of the speeding ticket, that's going to be this, right? So that's going to be 60 total. And then red car out of this total, red car is just that, right? So it'll be 15 out of 60. When you reduce it, will be 1 over 4 or 0.25, right? So that's how you're going to find your conditional probabilities. I am going to work on 2 more problems that's similar to example 2 and 3. So before we do this exercise 4 and 5, maybe you can try this out before you watch this video.